the maximum, minimum. For the first problem, number 7 wants us to find the maximum, minimum, the intervals where the function is increasing and decreasing, the domain, and the range of this function on the graph to the left. The maximum is going to be right here, where the function has a local maximum of y equals 6 at x equals 4. The minimum is going to be right here, where the function has a local minimum of y equals -1 at x equals 3. The graph is increasing from x equals -infinity, anywhere down here, all the way up to x equals -4, and from x equals 3 all the way to positive infinity. The domain, which is all of the possible x values, ranges anywhere from -infinity all the way to infinity, since the graph doesn't actually end. The range also goes anywhere, the y values go anywhere from -infinity all the way down here, all the way up to positive infinity up there. For number 9, we need to find f of g of x and g of f of x using f of x equals 3x plus 3 and g of x equals 5x squared plus 5x. In order to solve this, first we need to plug the equations for g of x into the equation for f of x. This gives us 3 times 5x squared plus 5x plus 3. When we distribute the 3, we get 15x squared plus 15x plus 3. And that's our answer for the first part. Then when we plug f of x into g of x, we get 5 times 3x plus 3 squared plus 5 times 3x plus 3. First we distribute, or we multiply 3x plus 3 times 3x plus 3, which gives us the 9x squared plus 18x plus 9. At the same time, we can distribute this 5 to 3x plus 3, which gives us 15x plus 15. Then we distribute this 5 to this trinomial, which gives us 45x squared plus 90x plus 45, and we still have the plus 15x plus 15. Then we combine everything, all of our like terms, and we simplify it to 45x squared plus 105x plus 60. For number 10, we have f of x equals 4, the square root of x, and the problem says that g of x is the graph of f of x shifted down 3 units and left 1 unit, and we are supposed to write a formula for g of x. In order to write this formula, we use the equation f of x equals a times the square root of x minus h plus k. Since we're shifting down 3 units, h is equal to -1, and since we're shifting left 1 unit, k is equal to -3. When we plug in these values, we get the equation g of x equals 4 times the square root of x plus 1 minus 3. Number 13 wants us to find the inverse of f of x when f of x equals 4 plus the square root of 6x plus minus 6. To solve for the inverse of f of x, we need to swap f of x and x in the equation and then solve for the new f of x. When we swap our x and y's, we get x equals 4 plus the square root of 6y minus 6. Then we subtract the 4 over, which gives us x minus 4 equals the square root of 6y minus 6. Then we square both sides to get rid of the squared root, so we have x minus 4 squared equals 6y minus 6. We add the 6 over, then we divide both sides by 6, and we end up with the inverse of f of x equals x minus 4 squared plus 6 divided by 6. For our final question, number 23, we need to divide 4x to the power of 4 minus 5x to the power of 3 minus 3x squared plus 5 by x plus 3, using this chart for synthetic division. After setting up our first row with the coefficients from each term and putting our -3 from the x plus 3 right here on the outside, we drop the first number down and then multiply it with the -3, which gives us -12, which we bring over here. Then we add -12 and -5, which gives us -17. We multiply that by the -3, which gives us 51. We add that with the -3, which gives us 48, and we repeat this process until all of our boxes are full. Then we write out our answer with each coefficient having 1 degree less than it originally did, and we put our remainder of 437 over x plus 3. This gives us the answer of 4x cubed minus 17x squared plus 48x minus 144 plus 437 divided by x.